In the previous video, we show you how you can declare a class called points, and then we illustrate the difference between when you have primitive values like an integer. And when you do assignments over here, let's say integer I is assigned to I, integer j is assigned to I. So here I is storing some integer value which can be copied over to be stored into j. Okay, the same principle applies when we say, let's say point p1 and p2. Over here, when we say p1 is assigned to p2, it's a slightly different way of thinking, but the same principle applies. So basically p1 and p2, they both store addresses of points. And now when we say p2 is assigned to p1, that means we're going to store the address that is stored in p2 at the moment and put it into p1. If p1 already stores an address at the moment, just replace it. Okay? So the effects of doing this is, as we illustrated in the iPad, p1 and p2 will be pointing to the same objects afterwards. And this creates something called aliasing, which means the same object whose address is stored in multiple variables, in this case p1 and p2. And aliasing effects, as we illustrated in the previous video, is simply saying if you try to use, for example, one of the names, for example p1, to actually call some mutator method to change the attribute value, let's say p1 and move up 3, the effects which will increase the p1.y from 5 to 8. So this effect is also visible by all the other names that store the same address. In this case, if we say p2.y, we'll also see the value 8, the updated value. Okay, so this aliasing effect is very important for you to understand. If you still got some trouble with this, refer to the previous video. Okay, so now in this new video over here, we're going to show you another class. Given that we know very well about the aliasing effects, so now in general, in your model view controller, the model components may contain more than one classes for you to develop. That's the more general case. It's much more frequently the case than just a single class as you did in the previous labs. So that's why we want to show you some simple examples so you can extrapolate to other cases for your labs. Okay. So now, let's first of all create a new class over here. Okay, let's right click on the package over here and create a new Java class. Let's call that point collection or collector. How about that? Collector. Apparently, just literally speaking, this is going to be a class that represents a collector of multiple points. And we are going to, let me just create a class first and then I will tell you what to do. Okay, so now we're just going to delete this, so we got an empty class to start with. So over here, we're going to show you not yet the perfect solution for a collector. Later on, we're going to teach you about arrays, which is a primitive data structure in the course, but we do not have to worry about it at this point. What I will show you is, let's say we know exactly how many points we're going to store in this particular point collector. Let's say we store exactly 2 points, let's say. So now the assumption is we know that each point collector object stores exactly 2 point objects. Okay, so let's say that's the case. And later on, after we teach you array, we can make this constraint relaxed. But we'll talk about it later in the later tutorial video. For now, we just assume we know exactly 2 objects will be stored. Okay, let's try that. Okay, what we will do is, so now let's show you how you can do that. So far you have been used to things like an integer, maybe I, and also double weights or character C or Boolean B. So these are the so-called primitive types. So these are the primitive values, which means they do not represent any address value in the memory. We only got address to be stored for reference variables. Okay, so now I'm going to show you a new way of doing things. Okay, every principle that we learned before still applies, but it's just a slightly more complicated thing. But given that you already understood the previous video about reference aliasing and how you can assign between reference variables, this new addition should not be too bad. Okay, so what I would do is I would say point P1, okay, and then point P2, okay. You can see that it's already different from what you have done so far. we have points over here. Point is capitalized. In Java convention, capitalized word means it's a class name. Whenever you put a class name over here, that means P1 and P2 are of reference types. Okay, let me just write it down. Attributes P1 and P2 are with reference types because point is a known class name. Whenever you use a known class name, in this case point, because we created this point class over here, so the point there is referring to this point class. Okay, and then when we go back there, so the point over here is referring to just that class that we just created, and then P1 and P2 are just separate placeholders. Okay, and the same principle applies. So we can say here P1 and P2 are reference variables declared to store addresses of, okay, you can see address is really important, addresses of point objects. Okay, and then I'm going to show you how you can visualize this in just a moment. Okay, so now let's say, and then let's define the constructor right away. Okay, so let's define the simple ones, and then I will show you two different ways of doing things, which are completely equivalent. You can choose which one to use for your app. So now let's say point collector, and then over here, let's say we take no parameter over here. That means P1 and P2, they would not be initialized. Okay, so that means we do not, okay, let's say in this version of constructor, we do not initialize reference attributes P1 and P2, meaning that they start with their default value. Okay, and we'll see exactly what the default values are in just one moment. Okay, and then I will draw some. Let's use a debugger to illustrate, and then I will show you on the iPad to visualize it. Now let's go to the point tester class that we have before. Let's be clean. Let's define another tester. Let's say point collector tester. Okay, let's say new, and then Java class point collector class. Right, and then over here we have, let's see what we can do over here. For the point collector class, oh, beg your pardon, I named the wrong thing over here. Let's rename this class. Okay, so let's right click on this class over here. I meant to say point collector tester. Okay, right click on the class and go to refactor, and then go to rename, and then we say point collector tester. Okay, that's what I meant to say. And then we declare the main method. Okay, public static void main string arts. Right, so now let's see if we since we already got a constructor for the point collector. Let me just get rid of point tester here. Okay, so now we already got point collector here that we just created, and it has already a constructor which does nothing to initialize the attributes. And then in the point collector tester, we'll simply do the following. Point collector, let's say PC, is assigned to new point collector. Like that, exactly just like that. And we want to see exactly what the values are for P1 and P2 without any initialization. We want to see exactly what it is. Okay, why don't we try? Let's put a breakpoint over here, and then we will run the debugger and see what happened. I think somehow the reason that it simply displayed the result from point tester was because we can memorize this from the previous execution. So what I gotta do is I have to right click on point collector tester and then say run point collector tester.main. That's what I should do. And then I'll run the okay. So I'll run a debugger actually. So let's do it again properly. Right click on this class over here, and then I'll say debug point collector main. Okay, that's exactly the way I meant to do. Let's do that, and then you will see the execution pause over here. Let's now walk into this particular object creation. So rather than saying step over, we're going to say step into. If you say step into over here, you can see now we are in the context of point collector. And we're going to execute this constructor over here. Let's say step over. Okay, so now we are at the end of the constructor. We are curious about what the P1 and P2 is. And what's really this? This is a context objects. If you look at the point collector tester here, the context object is PC. So now we are really talking about PC.P1 and also PC.P2, right? We got P1 and P2 over here. Okay, let's go back to point collector tester over here. So we know that it should be PC, and then should PC.P1, PC.P2. Okay, let me just go back here, point collector here. And now under here, you can see P1 has the value null. So null is a special keyword in Java. Every time if you declare a reference variable like a P1 and P2 of some class type, if you do not initialize the reference variable, they always have the default value called null. So default value is simply some value the compiler or the runtime will assign to the variables if you don't initialize the variables. For integers, they will be 0. For doubles, they will be 0.0. For Boolean, they will be false. For yes, so these are the common ones. Okay, but for reference variables, if you do not initialize the reference variable, they will simply just be null. Okay, let's now see how we can visualize this. Okay, let me just stop this. Okay, let me go back to the point collector tester over here. Let's see exactly what happened on the iPad. Okay, so now over here, if you have the following over here, we say point collector PC is assigned to new point collector. Okay, so this is the first version of a constructor. Now, let's remind ourselves, the way we draw the objects for point collector depends on how many attributes they have. We got exactly 2 attributes, P1 and P2. Okay, so the way we're going to draw that is, like this. Over here. So we're going to create a new object over here whose type is point collector. And then we have 2 attributes, P1 and P2. Okay, and then we also got PC is pointing to this point collector objects. Okay, the same as what we learned before. Now, the question is, what should we fill in over here? P1 and P2. Thinking this way, P1 and P2, as we learned from the previous video, when you declare P1 and P2 as reference variable, that means P1 and P2, they should store some address of some objects, right? P1 and P2. But in this case, in this particular constructor over here, we do not actually, let me stop the debugger as well. So in this particular constructor over here, we actually do not try to initialize the 2 attributes P1 and P2. So what we should do is, let me just stop the debugger now, just otherwise point collector process. Okay, so now what we'll do is, let's go back to iPad over here. You can see that for the default constructor, we are not trying to store any addresses to P1 and P2. So that means they should have the default value now. Okay, so that means P1 and P2, they are simply pointing to null in the beginning. Okay, you can think about is they're going to point to something as a reference variable, and at the moment it's simply just null. That's conceptually how you can draw that. Okay, you can see that now the difference between declaring reference attributes versus primitive attributes. In the case of integer or Boolean or character, you can simply put some value inside the box over here, conceptually. However, in the case of reference variable, you can see P1 over here is a reference attributes. In that case, P1 and P2, they are going to store addresses of point objects, which means they should point to something. At the moment, because we do not store any addresses to P1 and P2 to begin with, so they should both store just null. Okay, That's how it works. Now, then the question is, how can we define the class so that later on we can actually store something to P1 and P2? Okay, that's something we're going to do. And this will have to do with how you learned about aliasing from the previous video. Okay, let's do that. One way to do it is you can say void, and then we'll do, let's say, set point 1. Okay, how do we set a point 1? So we can say, so now for the parameter, you can also declare a type that's of type some class. Okay, so you can say point P. Okay, set point 1 and then point P. Okay, I will illustrate how this can be understood in the iPad in just a moment. So and then set point 1, and then we'll say this dot P1 is assigned to P. Okay, and similarly, I can also do the following. I can say void set point 2, and then we can say point P. This dot P2 is assigned to P. Okay, so now we have these two mutated methods over here, and then you can see the parameter type over here is also very different from what we learned before. What we learned before, parameter type can only be primitive, like an integer, boolean, character, or sometimes string. But now, in this case, we simply put some reference type, especially the class that we just declared. That's how you draw connection between the classes. Okay, let's see how we can call these methods, and then I'll show you how you can use it. Okay, so now let's go back to tester over here. Let's say we got, let's say point, let's say point 1 is new point, and then we have, let's say 2 and 3. Okay, and then point 2 is new point, and then 4 and 5. 2, 3, 4, 5. Okay, and then let's make sure I spell that properly. Okay, let's see what's going to happen after these lines. Okay, let's be careful. Okay, now I'm going to draw in the same diagram over there, and then I'll show you exactly what's going to be the effects. Okay, so now let me go back there over here. So let's okay, after this, what we say is we got point 1 is new point, and then we have 2 and 3 over here, and also we got point, so here we got point 2 is assigned to another new point, in this case 4 and 5. Okay, so how to visualize this should not be strange to you. So we're gonna do exactly, we're gonna create two objects over here. Let me draw them over here. So now we got two objects here, point, they both have x and y. One is 2, 3, and it's pointing to by point 1. Okay, and also we got another one. Let me put it here. And then here we have point. We also got x and y. That's 4 and 5. And this is point 2. Okay, like that. Okay, so now this is what we have got so far from these three lines in the tester. Okay, so now you can see up to now there is no connection between these objects. You can see we got point collector over here. Also, we got points over here. They have no connection whatsoever, because you can see that the arrows for P1 and P2 over here, they're simply pointing to null, as we tried to explain before. But we can do the connection by calling the mutated method that we just defined over here. If you go to point collector here, we got set point 1 and set point 2. That's what we're going to do. Okay, let's see exactly how this is going to be done. Let's just do one, and then the other will be completely symmetric. Okay, so now what we'll do is we'll say PC dot set point 1, and then we'll say point 1 over here, and also PC dot set. Let me just do this one only, and then try to illustrate. PC dot set point 1 and then point 1. Okay, so now this is the most critical line, so I'll just put it here. So now you can think about, we do step by step. So step 1, 2, 3, and 4 over here. Okay, and this step over here, we're gonna say PC dot set. 0.1. And then we'll pass 0.1 over here. Okay, just double check. That's really the line we wrote on the tester. Okay, so PC.set 0.1 and then 0.1. Okay, so how is this line going to execute, right? So let's also put the relevant attributes and also relevant attributes and method into context. So what I will do is I will just do it here. Okay, so let's remind ourselves what we have from the previous one. Okay, so remember we have a class called pointCollector. And then one of the attributes is is P1. Okay, one of the attributes for pointCollector was P1. Okay, I'm just going to put P1. So we got point P1. And also we have a Mutator method over here called set.1. Okay, void set.1 over here, and also we have point P over here, and then over here the implementation is simply this dot P1 is assigned to P. Okay, this dot P1 is assigned to P. Okay, so now we're calling this. So let's see exactly how this line over here, which I'm going to highlight over here, how this line over here can be executed according to how we define set.1, because we're calling this this method here. Okay, so now to really understand method call, we have to understand what the context object is. First of all, let's see what the context object is. You can see PC is context objects, and the dot over here means we're going to use the address that is stored in PC and locate the objects. And we know that PC is pointing to this object here. So we talk about this object here, right? And then when we say set.1, it's talking about this method over here. And we are passing 0.1, okay? So we just do the same replacement as we did before. So 0.1 is going to replace every occurrence of P in the parameter. Let's do that first, okay? So that means the P over here is going to be 0.1. And also the P on the right hand side over here is also going to be 0.1. And also, as we said before, PC is the context object. So this will be replaced by PC. So now what this assignment boils down into over here is as follows. I'll write it down separately. So that means what we got is PC dot P1 is assigned to 0.1. So now to really understand how this line works, that's why I actually try to teach you about aliasing and reference variable assignments in the previous video. So now hopefully everything will make complete sense. When you say PC.P1, I'm referring to, so PC is here, PC.P1 is referring to this particular reference variable over here, which can store some address of some point objects. And now when I say it is assigned to 0.1, what is 0.1? 0.1 is over here, which actually stores some point objects. In this case, 0.1 is storing the address for this particular objects over here. Okay, and then 0.1 over here is going to store the address as follows. So whatever address that we have here for 0.1, I'm going to trace this in the debugger for you as well to make sure you got complete understanding. So now when we say PC.P1 is assigned to 0.1, that means PC.P1, this particular placeholder, is going to store exactly the address that is stored in 0.1. So visually speaking, how do we redirect the error as we saw from the previous video? In this case, what we will do is as follows. That means PC.P1 is not going to point to null anymore. Instead, PC.P1 is going to point to wherever 0.1 is now pointing to. So now again, we have the aliasing effects as we talked about in the first video, in the previous video. So you can see now why understanding aliasing and reference assignment is so crucial. So now what we have is, after this particular set point 1 mutator call with point 1 being the arguments, the inputs. What we have done is now we have drawn a connection between this point collector called PC and also this point object called point 1. Okay, so now after this, we really have PC.P1 is also referring to this object over here. That's what we have. Okay, similarly, we can also do things like this. We can also do PC.set point 2, and then we can set point 2. Okay, what we'll do is PC.set point 2, and then point 2. That's what we can do. And you shouldn't be too surprised. What this will do is as follows. What this will do is it's going to say for PC.P2, rather than pointing to now, it's going to point to wherever this point 2 is pointing to, like here. Okay. So now diagram is becoming a little bit messy, but what I would make sure you follow the step. I'm going to redraw the diagram very quickly, and then we're going to talk about how you can make some more methods in your point collector. Okay. So now after these two lines, we have done two connections for the classes. Okay. Let's make sure we got that. Point 2. Okay. What we'll do is we want to make sure we have. Okay, we got all the lines from before. Okay, so now let's just redraw the diagram very quickly. Okay, so what we have done is so far from the these lines over here. Okay, let's make sure we just draw that. So PC is now pointing to a point collector objects. And then we have two attributes, P1 and P2. P1 is pointing to some point objects over here, which at the same time is also being pointed to by point 1. Okay, and then here we got X and Y, we got 2 and 3. And also P2, PC.P2 is now pointing to another object over here of type points. And also we got X and Y, so we got 4 and 5. So this is at the same time also pointing to by point 2. So we got two instances of aliasing. Okay, let me just make sure I can. So you can see the first instance of aliasing is like this, and the second instance of aliasing is over here. Okay, so drawing errors is really important for understanding the object behavior. Okay, so what we will do is we will try to develop a little bit more methods for you. Okay, so now because of aliasing, so let me just say one more thing. Okay, if you try the following following comparison in Eclipse, it's not Eclipse, in Azure Studio, you can see that they should be true. Okay, when I say PC.P1 equals 0.1 versus PC.P2 equals 0.2. What do that mean? What do they mean over here? When I say PC.P1, I'm really referring to this arrow over here, PC.P1. And then is it pointing to the same objects as pointing to by point 1? Yes, it is. Similarly, when I say PC.P2, so PC is referring to this object here, and then PC.P2 is talking about this arrow over here. Is it pointing to the same object as pointing to by point 2? Yes, it is. So both will be true. So you can also put them down over here. Okay, you can see it's out. So I'll just say PC.P1 equals 0.1. And also, since in the other print line, PC.P2 equals 0.2. Okay, just as an illustration for you. Let me just execute the code and make sure that they are really the case. Okay, true and true. Okay, and then what I want to do now is to show you how you can develop a mutator method. Okay, and then also another accessor method. So now let's go back to point collector here. Let's say we want to do the following. Let's say void. Let's say we simply want to do, let's say move up. Okay. Let's say we have a point collector here, and somehow we want to move one of the points up it can be either P1 or it can be P2, depending on what we want, right? So what I can do is I can say string which point, and then I can say move up by how many units. Okay, over here, and then what we can do is I'll just write down the code for you. You can study the code a little bit later, but I'll show you on the iPad here, and then I'll finally show you some debugger running. So now what we can say is, now let's say if which point, okay, it should be which point rather than which point v. If I say which point dot equals, let's say, let me just say point 1. This string here just for illustration. And then what we can do is we can say p1 dot move up, right? Remember, move up is actually a point method by this much units. Let's say else if which points dot equals, and then over here we can say point 2. In that case, we can say p2 dot move up, and then we can pass units here. Okay, so what does that mean? Basically, we are calling the move up methods in the point class as helper methods. And then we say that in this point collector class, since we got 2 points, P1 and P2, we want to know exactly which point, either P1 or P2, to invoke this method. And now because from the previous illustration, we know that PC.P1 and also PC.P2, they are already referring to the some point object over here. In that case, if we say PC P1 and then say move up, it's going to change this object over here. If we say PC.P2 and then move up, we're gonna change this object here. So it depends. So let me illustrate to you. Okay. So now let's just go back there and then try to do that. So now what I will do is, so now this is after the setup. So now we'll say s out. Okay. Let me just do a little bit more. Let me just do it here. Okay, let's say, let me just, before we try to set up 2 points, we'll say s out. Okay, we'll say before setting P1 and P2 of PC. In that case, so now how do we actually do some toString method? Why don't we try to actually do this very quickly? So you go to point collector class. Let's say we also define the toString method over here. So here I can also show you a good pattern. You can just, a good practice is for every class you define, you also have a toString method over there. We already got a toString method for the point class. So now we will also like to have a toString method for the point collector class. Let's see what happened. So we know that basically string s is empty string, and eventually we want to return s. And over here we can say s plus equal, and then we know that we actually store P1 and P2, right? So now we can actually try to call the toString method there. But here you gotta be very careful because P1 and P2 actually can be null, which means they might point to some, initially they might point to null as we, let me just see here. They might point to simply null, which means they haven't been connected yet. So we're gonna be careful here. So what we can do is the following. You can say if s dot p1 equals s dot p1 equals null. So that's how you sorry, not s dot equal. Okay, this dot p1. What you can say is this dot p1 equals null. Then we'll simply say s plus equal 0.1. Let's say p1 is simply null. Otherwise, we can say s plus equal, and then we can say p1 dot toString. That's what we can say. So basically, what I'm trying to show you here is, if p1 happens to be null, that means p1 has not been initialized yet. If you try to call a method on some null objects, it's going to give you something called null pointer exception, which is not good. It's some runtime error you want to avoid. Okay, so every time if you want to call some methods on a particular object variable, you want to make sure it is not null. Okay, that's why I'm having this check here, and we can have a similar similar writing for p2. So I can say if this dot p2 equals null, that means I will say s plus equal p2 null, and then otherwise I can say s plus equal p2 dot toString. Basically, so this method shows you two things. First, whenever you want to call a method on some objects, you always want to check to see if in the case where it is null, what should you do? In the case where it is not null, you can call some methods on the objects. That's the first thing to learn from this method. And the second thing to learn is you don't have to just put all the description for the toString from scratch. You can simply reuse the toString method from another object. So that's something you can feel free to reuse for your lab exercise. Okay, that's what we have. And then let's go back to our point collector tester over here. So now what we can say is, before setting P1 and P2 of PC, we can say PC dot toString. Okay, let's run it and see what happened. And then we'll say after as well. Okay, in that case, let me just add a new line. Okay, so let's go back to point collector over here. So now we can say, now between P1 and P2, we can say s plus equal a new line over here. Right, let's go back there and let's just double check. Run it again. So now you will see that before setting P1 and P2, we got P1 null and P2 null. Let me just do another one here. Before setting P1 and P2, let me also put a new line here. So it was it's just pretty printing the console. I just launch play again. So what you will see is before setting P1 and P2 of PC, you got P1 is null and P2 is null. Okay, that's what the reason is. You actually enter this particular if branch because this P1 is null, it's not initialized yet. And also this P2 is also null because it's not initialized yet. Okay, let's now go back to after we actually have set the P1 and P2. After setting P1 and P2 of PC, because we call these two mutated methods, after that, what would PC look like? Okay, what will be the toString? So now if you do that and execute again, what you will see is, you can see after setting P1 and P2 of PC, we got 2.0, 3.0, 4.0, 5.0. That's exactly what this diagram is showing to you. PC.P1 is referring to this point over here, which is 2 and 3. And PC.P2, which is referring to this object over here, has 4 and 5. Okay? Hopefully that makes sense to you. So this is something you should really try to practice over and over. Okay? So now let's do one more thing. Okay? So now let's say after setting P1 and P2, what we want to do now is to say this. We want to change PC.P1. We want to change the P1 of this particular object called PC. How do we do that? Remember we just defined this particular mutated method here, which is called move up over here. Okay, so let's see how we can do that. So you can say PC.move up over here. Let's just pass. Let's assume that whenever you pass which point, it's going to be either point space 1 or point space 2. If I say point space 1, what you will do is, and then move up, let's say for 3 units. Okay, what this will do is, conceptually, it's going to say PC dot, I'm going to show you this in the debugger as well. Okay, but we'll do that in just a moment. And then we'll say PC.P1 over here, it's going to be moved up by 3 units. So we'll change this particular object from 3 to 6. Okay, let's see if that's really the case. So now we can see, let's say we just do this. After moving P1 up, PC.P1 up. Okay, let's see what happened. If I do that over here, you should see exactly the effects. Okay, after that, you will see that it's moving up from 2.0, 3.0 to 2.0 and 6.0. Okay, so that's basically what happened. So let's just basically after that, we are actually just replacing this particular point over here by 6.0. That's what we have done. Okay. Now, finally, I want to just show you the debugger. Okay. Maybe before the debugger, let me show you one more thing. Okay. So now let's go back to the point collector over here. I'll let you write a tester for this additional things I'm going to show you. I'll let you run it, but I want to show you 2 more things. First of all, the constructor over here does not initialize any of the points P1 or P2. What you could have done, you can always provide different options of the constructor. What we can do is we can do point collector, and then over here point collector, and then we're gonna pass. So let's say this time we use a different version of the constructor. So now let's say point P1 and point P2. A little bit like a mutated method here, like a set point 1 and set point 2. Okay, similar. Just to say initially, when we first create a PC objects, a point collector object, we want to pass P1 and P2 directly, just for the first time. We can say this.P1 is assigned to P, and this.P2 is assigned to P1 and then P2. Okay, that's what you can do. Again, because P1 and P2 over here, they clash with the names of P1 and P2 over here. That's why we say this.P1 and also this.P2 on the left-hand side. Okay, so this one will also do the same trick. Basically, this one this one does one additional step in the beginning. It simply connects the points of P1 and P2 of the point collector to some other objects in the very beginning. Okay. So now, let me just do one test for you, and then I'm going to run a debugger for you as well. So point collector, and then we can say PC2 is assigned to new point collector over here. I can simply say, if you like, you can just do, let me just create another 2 points. Okay, so you're not really confused. So point 1, point 2, and also point 3, point 4, point 3 and point 4. So 2, 3, 4, 5, 6, 7, and then 8 and 9. And then here we got PC2. Okay, now we're gonna pass point 3 and point 4. Okay, what this does is I will leave the visualization to you as well, but I'll just give you some idea. The above line is as if, okay, let me just change the comment style. The above line is as if we did the following. We called the first version of the constructor to say point collector PC2 is assigned to new point collector over here. So this is the first version without initializing P1 and P2. Okay, and then we say PC2 dot set point 1. Point 3, and also PC2 dot set point 2, and then over here we say point 4. That's what we have. Okay, sorry, just cancel that. Okay, that's as if we have this. So now I'll leave the visualization and debugger for this particular block of code for you. I'm just trying to show you can have different ways of initializing your attributes. You may choose to leave the null to begin with, like the first version of the constructor, or you will try to pass some points objects in the beginning. It's completely up to you which one you want to choose. Okay. So now, finally, I want to just walk you through about exactly how things are going over here. Also show you in the debugger, so you can also try to reproduce this exercise for yourself as well. I'll put a breakpoint over here, and then meanwhile, I'm going to start a new page over here. We'll trace step by step. Okay, let's see exactly how this is going to work. So now, let's now run the debugger over here, and then we should pause at the first line over there. Okay, now we are paused over here. What's going to happen if we do this line over here? So this is going to create a new point collector, and then call it the first version of the constructor. And then let's see what's going to happen here. Let's say if we say step over, what you will do is you can see P1 and P2, they are simply just null to begin with. Okay, what we have done is after line number 5, I'll refer to the line number on the left panel here. After line number 5, what we got is we have a PC referring to some point collector objects 490. Okay, let me just draw that. So we have PC, so stores the address of point collector at 490. Point collector at 490. Okay, it's now pointing to some point collector objects. Okay, and in the beginning, over here, if you expand this over here, you can see that P1 and P2 are both null. Okay, you can see that. So we got P1 and P2. Okay, you can see PC.P1 and also is referring to null, and also PC.P2 is also referring to null. Okay, that's what we start with. Okay, so completely consistent with what we said before. Okay, I will step over. So now what we have done by lines 6 and 7, which you should be very familiar with how to visualize them. But I just want to say that point 1 and point 2, you can see they are separate objects. One is 493, the other one is 504. Okay, let's do that as well. Okay, that's also going to be important for the tracing. So after that, what we got is we got point 1, which is pointing to some point objects over here. Similarly, point 2 is also pointing to some point objects over here. And then point has x and y, and also point has x and y. And for point 1, we got 2 and 3. 2 and 3. And for point 2, we got 4 and 5. Okay, 4 and 5. Now, what about the address? Address is really important. That's why I'm showing you the debugger. So point 1, point at 493. Point at 493. And what about point 2? Point at 504. Point at 504. Okay, the address, the absolute value is not really important, but I want to show you when we try to connect point collector with these 2 points, we really only do address copying. That's something I want to show you. Okay, so now let's go to the next line. So now this is the line I would like to go step into. Okay, so now you can see that PC, which we have over here, which has P1 and P2 both being null at the moment. And then we pass point 1 over here, which has the address of point at 493. So something we're trying to do. What I would do is I'll step into this particular method here and see how it is executed. So what we'll do is we'll step into it. Oh, beg your pardon. I should have stepped into, but I should said step over. Can I just do it again? Okay, I really want to stop at that point. Okay, let me stop the debugger over here, and then I will just run the debugger once more. Okay, and then I'll go to exactly that line for you. Okay, but maybe the address might change, but I will see because there's different run. Okay, step over, step over, step over. Okay, so now 493 and 504. Okay, that's the same as before. Very good. Okay, so now we go to this line over here and we'll step into it. Okay, remember point 1 has the address of 493 over here. Okay, it has 493 over here. So now we'll step into it. So now you will see that now we are in the context of point collector. And then the current object, you will see that current object is point collector 490, which is this object over here. So now we are really dealing with this object here. And then we are trying to do set point and then point P. What's P? You can see if you move your mouse over P over here, or you can see from here. P has the address of point at 493. It's really this point object we are talking about, this one here. Okay, point 1 over here. And then we are trying to do this particular assignments. Before we do the assignments, PC.P1 is referring to null over here. And then we're going to assign P, which is has the address of 493 over here. We're going to assign that into this.P1. So let's predict what's going to happen. That means what's going to happen is, now PC.P1 after this, over here is going to store point at 493, which is going to copy exactly this address here. That's what's going to happen in hardware. Okay, and then conceptually, what's going to happen is, rather than pointing to null, it is going to point to this particular object over here. That's what's going to happen. Let's make sure that's really the case. Of course, in the debugger, they don't really show you the arrows and diagram, but you want to know this to link the diagram to the debugger. Okay, so now I want you to compare something very carefully. This.P1 is null at the moment, and P is with the address point at 493. Watch what's going to happen here. If I say step over, you can see that this.P1 has been assigned the address of the same as P. So now P point at 493, point at 493 as well. That's exactly what I show over here. Okay. Similarly, let's just go so here. So this is the first line. This is something we just traced. So now for step point 2, it'll be something very similar. Let's step over. I will let you do the step into as an exercise for yourself. And then if I say step over here, what I want you to see is this PC.P2 has the address of point at 504, which is the same as point 2, which is 504. That means after calling PC.setPoint2, this address is going to store point at 504, which means conceptually, rather than pointing to null, it's going to point to this object over here. Okay, so that's how we draw the connection between the 2 points. That's how you see from the debugger. You should know the address, how the addresses are copied, and also how to draw the diagram. Okay, finally, what we can do is final exercise before I end the video. So now if I go to this line here, when I say PC.moveUp, how is that going to work? Okay, let's step into it. If I say step into it, you can see that which point over here is point 1. Okay, that means this comparison over here is going to succeed. So now if I step over here, you can see now we'll do P1.moveUp units. Okay, what's P1? You can see P1 over here is referring to the address point at 493. Right, point at 493, which is pointing to this object here. Let me just highlight that for you, which is referring to this object over here. Okay, the same as this one here. Okay, when we do that thing there, point at 493, when we say P1 move up, if we as soon as we do that, I want to show you one thing here so you can see exactly what's going to happen. Let's say this is P1 over here. You can say P1.y is exactly 3.0. I want you to look at another one. So this is actually point collector, and also we got P1. You can see the same address over here, the same address. That's why we got aliasing, right? The same address because PC.P1 is referring to this, and also we got point 1, which is also referring to this. Okay, so now what's going to happen is you can see that 3.0 and 3.0, they are the attributes of the same objects of address 493. As soon as I say P1 move up by 3 units, it's going to become 2 and 6. You will see that these 2 values over here are going to change at the same time to 6.0 because they refer to the same object. Let's try that. If I do that, 6.0, and also you will see point 1 over here, that's also 6.0. Okay, so now P1 is already gone simply because we have done the method, so it's gone. But what I want to what you really should notice is you can see this P1 over here, .y is referring to 6.0. That means after this method call here, we're going to have P1, PC.P1, PC.P1 is referring to this object over here, right? It's referring to this object here, PC.P1 over here. And then PC.P1, I want to know what it is for the y. And then so .y over here, it has been replaced by 6 because we move up for 3 units. Okay, so that's how you see from the debugger. I know that running the debugger is a little bit tedious and also a little bit difficult to really see exactly what's going on. That's why you have to rewatch the video for as many times as necessary for you to see the idea. Okay, I think that's about it. So let's recap very quickly for you. Okay, so basically for this particular video, I show you that based on the point and also aliasing discussion we had from the previous video, now we have another class called point collector. And the point collector class has 2 attributes, P1 and P2, of reference type, which means they have some class as a type. In this case, point. And then we show you 2 versions of the point collector, and then we also show you how you can draw a connection between the point collector and point objects, like what we drew over here. Okay, that's something you should really review. And also, we also have a move up method for the point collector, you can decide which point you actually want to move up to, and then it can be either if that happens to be point 1, and then we'll call the context object can be different. When we say point 1 over here, the context object will be P1. When we say point 2 over here, the context object will be P2. Okay, and also we show you how we can do the toString method based on the toString method of other classes. Okay, and also whenever you want to call P1 the toString, you better check that it's really not null. That's why we say if P1 happens to be null, you should not really call any method on that, because you will get null pointer exception. Okay, there are many things covered in this video and the previous one. The concepts are new to you, and they are not so easy for the beginner. So I would suggest you try to watch the video for as many times as you think necessary for you to understand the concept.